Okay, Lecture 2.2, Measuring Voltage. Voltage can be measured with several different instruments, used in different measurement applications. The first we'll talk about is the multimeter. A multimeter, such as the Fluke multimeter shown, Fluke is a very common brand of multimeter, shown in Figure 2.1, can be used to measure voltage, current, resistance, and sometimes capacitance. This particular one can also do capacitance and some diode tests. These small, usually handheld devices have two probes used in two different connections, high resistance and low resistance. High resistance connection. Each probe is connected to a location on the circuit in order to measure the voltage, resistance, or capacitance across the circuit connection, or connect the circuit connecting the locations. The hot probe is connected to the V or omega port. So we've got multiple ports down here, and COM is the ground, and then hot in high resistance connection, you're going to connect to this connection and that port. So if you're measuring voltage, or you're measuring capacitance, or you're measuring resistance, this is the connection that you want. And the probes, you touch on two locations in the circuit, and it tells you the properties in between those locations. Low resistance connection. In order to measure the current through the multimeter, the circuit must first be broken and the multimeter placed into the circuit. So now your circuit includes the multimeter, and you like to affect it as little as possible, as in the other case. So it provides very low resistance. It just passes the signal right through, but it measures some things along the way. Specifically, it's trying to measure the current. The hot probe is connected to the A for amp, MA for milliamp, or mu A for microamp ports. So when you're in that connection, you need to have the hot probe in one of these. This one if it's for small current, and this one if it's for high current. The dial selects the measurement mode. So the dial is here. This is DC voltage. This is small DC voltage. This is AC voltage. This is resistance. Also the yellow key Alt selects the capacitance. This is the diode. This is small current, and this is this is regular current, and this is small current, AC and DC. So in those cases, you have to move this over. So you're in this high resistance connection when you're in this mode, or this mode, or this mode, or this mode, but I believe also this mode. And then if you want to change these over to one of those spots, the hot over, then you can do this guy or this guy. So that's the broad overview of that. You want to be in high resistance if you connect across two spots, and you don't want there to be any current flowing through the multimeter, or very little as possible current flowing through. And that's why you try to have a high resistance in between your probes, whereas when you're in the circuit, you want to be as you want to conduct through the multimeter with as little resistance as possible. That's why there are the two modes. Great. So those are the different possibilities. Awesome. So let's talk about oscilloscopes. An oscilloscope is an instrument that measures and displays a voltage signal through time. Okay, so unlike the multimeter, which has just a digital display, it actually wants to show you a graph of what's happening through time. It allows us to zoom in on a window of time through which the signal is displayed. If the oscilloscope is properly triggered, the signal will appear stationary. This occurs when the window is set to a time interval that is an integer multiple of the signal's period. This allows the signal to trace over itself and appear continuous. So kind of the idea is you can imagine that you have a dot that's going along on a screen. It doesn't have to be a sine wave, but if you have a dot going along on a screen, and if the dot makes it all the way over here, and then you move it back to the left-hand side of the screen, and it happens to start at the same spot, so it cuts off and starts at the same spot, it'll retrace its steps, assuming the wave hasn't changed. You get a nice, steady, stationary wave on the screen. That's this sort of weird zooming in time that you can do. You can go to you can stretch this then down to, so you could be looking at I don't know, 5 milliseconds, for instance. But you can see it just fine. It's like a live signal, but it's really just a signal that's being traced over itself a bunch of times. Now more digitally than in actuality, but back in old types of screens, there were electrons actually flying across the screens. So this is the idea, the concept behind an oscilloscope. We're using the Tektronix DPO 2012B oscilloscope with the front panel shown in 2.5. The manual you can download from there. So this is the front panel. We've got 2 channels, okay, and the input impedance for these is high. Okay, I don't remember what the, it says right there, 1 mega ohm. So the input impedance is 1 mega ohm. Just like the multimeter in high resistance connection, these have high resistance. So if you connect probes across something, then you should see it shouldn't really affect the circuit when you connect it. It shouldn't be loading the circuit. So it shows you voltage signals on the screen. You can scale up and down. So channel 1 has this knob, so you can zoom in vertically, so increase the amplitude appearance or decrease it. And it's like changing the y-axis scaling. And then for each channel, so you can do that separately. And for time, you can zoom in time by turning this knob. Okay. The Waveform Inspector is really cool, and I encourage you to play with it, but don't do that first. That's not the way to zoom in time, for instance. It's the horizontal controls here. And then there are a whole lot of options. This is a very pretty advanced oscilloscope. They're pretty cool. But another sort of standard thing to learn about is triggering. So one way you can avoid having to know exactly what the period of your signal is that you can trigger your oscilloscope on a certain event. So often it's the rising edge of the voltage crossing over a threshold. Once that happens, you move the cursor back to the left of the screen, and it begins again. So it goes like that. So the trigger mode can give you the ability to lock onto your signal so that it retraces itself. So triggering is nice. You can trigger from one of the signals, or you can trigger from the aux in, auxiliary in, and either one is fine depending on your situation. You can trigger automatically or not. Also, there are different trigger modes too, so you can look in the trigger menu and see the different modes. There's like continuous run, and these sort of allow you to adjust that too. So I encourage you, it's one of those things you kind of have to play with. So play with it, see if you can get stable waveforms on the screen, yeah, see how it goes from there. Great. So this oscilloscope has advanced functionality, including cursors, so you can like move cursors around. It'll tell you like the distance between them, the voltage, and then the time. Signal averaging, so you can average a signal multiple times across the screen. Signal math, you can add two channels together. Fast Fourier transform, so you can actually see a spectrum, which is really cool. I might add another lab about that later on in the semester. It's like, seems pretty fun. And trace capturing as well, so you can save data from it. But it's not really the best way to do it. To save data, you should use the MyRios instead. They're better. So, also in the lab is the older BK Precision oscilloscope with the front panel shown here, and also a link to the manual. So this one's just got some older school ways of doing things. This is, you're gonna see like a green dot that moves around on the screen. The channel 1 and channel 2 are there and there. It's sort of the same setup, but not quite as flashy. Doesn't have some of the advanced functionality that the new one has either. So these connectors are Bnc connectors, and we'll talk a little bit more about those. But they're a type of coaxial cable connector. So yeah, we'll talk more about it in the next lecture actually. But those are the connectors you're looking for. Bnc are how you connect to these instruments, and most instruments in a mechatronics lab or most science labs. Bnc connectors. Okay. Onward.